Hey, welcome. This is the first calculus video. It's called Intercepts, Symmetry, and Intersections. So this is a picture of the bridge over the Savannah River, as it says down there in Savannah, Georgia. If you look at it for a few seconds, you'll probably see some possible examples of all three of these topics: intercepts, symmetry, and intersections. It's a big bridge. I like the picture. And work from math. So anyway, if we're going to start talking about symmetry, intercepts, and intersections, we probably ought to start with a general idea about what is an intercept. I think you know, have an idea that you know. You've probably seen the terms y-intercept since back in 6th grade, 7th grade, 8th grade, 3rd grade, I don't know. The y-intercept, there it is, y-intercept, and hopefully you've heard the word x-intercept as well, and the x-intercept is there. Right? And so typically when we think about what's an intercept, we picture some sort of a graphic interpretation as, you know, the place where it crosses the y-axis or the place where it crosses the x-axis, and that's all nice and good if you have a graph. So we want to formalize our definition a little bit and talk about that in terms of any situation. So the y-intercept is the value of y when x equals 0. The value of y when x equals 0. So if we look back at the picture, you know, that's the value of y right there. That's my y-intercept, and x at that point is equal to 0. So that's what a y-intercept is, the value of y when x equals 0. Rather than thinking about it as a location, let's think in terms of a math definition. That'll be helpful when we don't have a picture. Similarly, the x-intercept is the value of x when y is equal to 0. Okay, quick back to that other picture. There's my x-intercept at that particular point, anywhere along this axis, y is equal to 0. So that's how we find the x-intercept. Okay, so again, graphically it's where it crosses the x or the y-axis, but mathematically we want to just think about it as an actual value. It's the value of y when x equals 0. That's the y-intercept. The x-intercept, the value of x when y is equal to 0. So if we're going to try to find x and y-intercepts, we could try to graph this, but we'd have a hard time graphing it because it's x's and y's and cubes and things like that. So let's go with the definition. So to find the x-intercept, start with that one, x-intercept, we make y equal to 0. So we're just solving 3x squared minus 5 equals 0. And probably the easiest way is just to solve this, add 5 to both sides, that sort of thing. 3x squared is equal to 5. X squared is equal to 5/3. Divide both sides by 3. And then we'll go to the square root, so x equals plus minus square root of 5/3, which is a fine, legitimate answer. That would be my x. That would be my x-intercept. Sorry, a little froggy today. To find the y-intercept, I haven't spoken all summer. That's why my voice is not used to speaking. To find the y-intercept, we're going to make x equal to 0. So we're going to go 0 minus 5 equals y cubed. If you like, I'll be really formal. 3 times 0 squared, which is just 0. So this turns into y cubed equals negative 5. And so y is equal to the cube root of negative 5. And we can take the cube root of a negative number as a negative times a negative times a negative is equal to a negative. These two make the positive. Positive times negative gives you the negative. So we can take cube roots of negative numbers, can't take square roots of it. So this y-intercept is somewhere around the cube root of negative 5. I don't know where that is, but I'm going to say it's a negative someplace down in there. My x-intercepts of this thing are plus minus square root of 5/3. 5/3 is not quite 2, so I don't know. Like that. And I have no idea what this thing looks like, but I know that it crosses there, there, and there, so I could pretend we could, we'll get into more detail on how we might graph that. But for right now, finding the intercepts. X-intercept, the value of x when y is equal to 0, and y-intercept, the value of y when x is equal to 0. Okay? Symmetry. You know what symmetry is. It's that fold in half thing. where things line up nicely. That's what we're talking about. If we're talking about a picture that has symmetry about the y-axis, think of a parabola. You'll have to do a little pretending. It's not bad for having been out for a little while. Okay, when we're symmetric about the y-axis, I could just fold this thing over, and theoretically this would fold right on top of that. Okay? So what that means in terms of us is that if I've got the point x comma y here, I can fold that over and it would be reflected exactly right there. I should get a different color pen, but I'm not going to. So the coordinates of this other point is going to have the same y coordinate, but the x coordinate is going to be opposite, negative x. So when I've got symmetry about the y-axis, if I have xy on one side, negative xy is going to be on the other side. So we'll do a little test. Here's the rule, though. If I can take x comma y and change it into negative x comma y and get the same answer, and I probably should just do the example, but we're just going to go through the rules. If changing xy with negative x comma y gives me the same result, then I have symmetry. Now let's go with the example. So if I have y equals x squared, if I change my x to negative, y equals negative x squared. Negative x squared is x squared. So I get the same answer, the same original equation back by replacing x with negative x. Okay. Similarly, if I have symmetry about the x-axis, not bad. Let's go with a different color pen just for points. Okay. Again, I look at the point x comma y. I look at its reflection over here. Okay. It's going to have the same x coordinate. Its y coordinate is going to be the opposite. So what we do in this case to check for symmetry is we take x comma y and we replace like so. And so if we get the same result, that's what that says, same result. When we replace y with negative y, then we know that we have symmetry about the x-axis. Lastly, symmetry about the origin, and this one's going to be a little bit difficult to draw, but I think I'm up for the challenge. Like about that. And in this case, I've got the point x comma y here. And when we're talking about symmetry about the origin, the fold line is like that. So this maps down to there. And in this case, I have the point negative x, negative y. So in terms of the rule, I replace my x and my y with negative x and negative y. And if I get the same result back, start back with the original equation after I do a little math manipulation, then I know I have that symmetry. Okay. So, testing for symmetry. We're going to test for symmetry this way. We're going to replace, first we're going to go about, for symmetry about y. So we're going to place x with negative x. So y equals 4 times negative x squared times y plus 5. When I do that, negative x times x, or negative x times negative x turns into x squared. So this turns into 4x squared y plus 5. So check, back where we started. If I look for symmetry about x, I replace y with negative y. So I get negative y equals 4x squared times negative y plus 5. And that turns out to, I think, not be the same thing because I end up with, what, negative y equals negative 4x squared y plus 5. Get rid of the negative, I get y equals 4x squared y minus 5, which is not the same thing we started with. So I don't have that. And if I go about the origin on this one, and I don't have the room to do that, so I don't know what I'm going to do. Oh, that's what I'm going to do. Extend the page about the origin. I would then go with changing both things. Negative y equals 4 times negative x squared times negative y plus 5. And if you look at it, it's going to bring us essentially back to this situation here, and so it's not going to work. You can work through that a little bit on your own. Try this problem out if you want to. Y equals 3x squared plus 4xy plus 7, and see where it leads you. See if you have symmetry about y, symmetry about x, and symmetry about the origin. Follow that same process. We can check on that in class tomorrow. Okay? There's a problem for you to work on. Pause it if you need to. Finally, we get to points of intersection. And we know what points of intersection are. They're points where the two functions that we have intersect. Right there is a point of intersection. Right there is a point of intersection. Should have done that one in red so that it stands out. There it is. Points of intersection. So we know what they are. And essentially, x and y are equal in both functions at those points. That's what makes it a point of intersection. That's what we're always looking for, the values where x and y are equal to each other. So we're going to check into that. So the easiest thing to do is just do like some sort of substitution thing. Plug that in. This goes back to Math 2 when you're solving systems of equations. Plus 3 times, let's go with that color, 2 times 3x minus 2. That's all of this part here. Back to red, because that's what I started with, equals 14. So 3x plus twice 3x is 6x, twice 2 is negative 4, equals 14. Combining like terms, 9x minus 4 equals 14, 9x equals 18, x equals 2. Slow yourself down if I'm going too fast for you. X equals 2. And we just got to figure out what y is. Y is equal to 3 times x minus 2. That's x. 3 times 2 is 6. 6 minus 2 is 4, so y is 4. So we found the point of intersection for that particular curve. We can do it again with any kind of function. So same thing here. Let's go with that. Let me get rid of the red because we'll start with this. So I'm going to substitute in there x squared plus 4 times y, which is 2x plus 1 equals negative 3. So x squared plus 8x plus 4 equals negative 3. How do we solve this? It's quadratic, so we've got to use some sort of quadratic method. Typically, we want it to equal 0, so let's go with x squared plus 8x plus 7 equals 0. Quadratic formula works. This factors nicely. We'll talk about factoring if you want. X plus 7, x plus 1. And so my intersections are x equals negative 7, x equals negative 1. And let's see, when do those happen? Negative 2 times 1 is negative, or 2 times negative 1 is negative 2, plus 1 is negative 1. So in this case, y is negative 1. And in the other case, 7, negative 14 plus 1, y equals negative 13. So those are my points of intersection. Those are the places where the two curves meet. And that timer means I've got about a minute to wrap it up. Thankfully, we're at the last little bit. If you have questions, come and ask them. That's what we'll do at the start of class tomorrow. We'll try to clarify everything. I might have gone a little bit fast in a couple of places, so slow down, look back at it. Don't be afraid to ask questions. So we're talking about symmetry, we're talking about intercepts, and we're talking about intersections. Thanks for watching. Talk to you soon.